So, section 5-6, why do we take math? Well, there's lots of good answers to that question. The first can be general problem solving. We use it in life, but not algebra per se. Some people do, not everybody. General computation. Doing simple math in our head, it's good practice. We need that all the time. And the big one, model the world. Why do things happen when they happen? What's going to happen next? Can we predict? So we'll start with the model of the world. So, it's a linear model. What does that mean? It means the data looks like a straight line. For example, we look at this as your grade as a result of time studying. And we got one over here with your grade as a result of time on Facebook. So the more time you study, the better your grade will be. The less time you study, the more time you spend on Facebook, the worse your grade will be. Call this a negative correlation. So the slope is negative. Call this a positive correlation. The slope is positive. And since you guys already understand the basics of slope, that's not really that complicated. For somebody who doesn't really know slope, that's a very interesting subject. You guys are way ahead of that. Relatively no correlation. It's where the data is all over the place. You can't draw a line through it. Just random data. And pick a card out of a deck of cards and write down the number. Well, it's a 2, it's a 5, it's a 13, it's a king, a queen, whatever you get. Now, there's lots of things that we can model in the world that are linear, but let's not worry about what else we can model. Could do a simple model of traffic lights. So time to get to school if you drive. Number of traffic lights. More lights you go through, the longer it takes to get to school. How do we model? Well, usually we just get some data points. For instance, on number of traffic lights, we'd have to ask a ton of people, how long did it take you to school, and take you to get to school, and how many lights did you get through? And we plot them, and then we do the best we can, trying to put the curve through them. Then we look and we say, okay, what 2 points did we hit? Well, here's one here, and here's one here. Now that we have 2 points, we can go ahead and create an equation. We've already practiced that a lot. Let's do a real example. So, tricky part is getting it all onto the graph properly. Looks like we can start down here at 2800. There's 20 spots open. 4694 minus 2811 divided by 20 spots. Looks like we go about 100 each. It's a little bit tricky to write all that in, so we'll just go with 3000, 3200, 3400, and so on and so on. And on the other side, we've got 95, 96, all the way up to 04. Let's just use these numbers on the right. And that's 4 and 4 is 8. Looks like we put 1 everywhere, every time on the dot, on the graph. So we've got 20, and let's take a look at that. 20 spots divided by 8. Like 2.5 each would be perfect. 96. And if we made 2.5, that'd be 97. This would be 98, 97, 98. 2, 3, 4, 5, 2000. Let's see if I screwed up or not. It looks like I did it right. Lucky me. And you'll make mistakes on this a lot. Don't be shy about going back and fixing things. So the first one's 2811, about there. 97, which is here, about there. 98, about there. 99, about there. 00, about there. 01, about there. 02, a little bit of a jump there. 03, and 04. Now that data definitely has a curve to it, but it has some linearity, so we're going to give it a shot. See if we can find a curve that fits through. And there is no right or wrong way to do this. You just guess the best you can. Yeah, we got 3, 4 on one side, 3 on the other side. These are kind of close. That one's off a little bit. That looks pretty good. So now we need the points. This point is 2003, 4115. This point is 1999, 3247. So now we got a model. Find the slope first. X1, Y1, X2, Y2, M equals 3247 minus 4115 over 1999 minus 2003. M equals negative 868 over negative 4. M equals, nice number, 216. So it looks like it goes up 216 for every one. Now we're going to plug it back into point slope. Choose the one on the bottom. So y minus y1 equals m times x minus x1. In this case, we'll use the 2. Y minus 3247 equals 216. X minus 1999. Distribute. Four, 3, 1, 7, 8, 4. Add to both sides. Y equals 200. 16x minus, oops, my bad. Minus 428,537. There it is. Let's try one point, see if it makes some degree of sense. Let's try 2002. So 216 times 2002 minus 428,537 gives us 3895, and 2002 was 3725. Looks like we've done a decent job. That's it. That's how we linear model by hand. Time consuming, to set up. Once you get the graph, you're good to go. Make sure you find 2 points, and then you're back to point slope. Convert it over to slope intercept. Good luck.